Good afternoon, my YouTube viewers. It's Crystal here. And basically what I wanted to do is I wanted to make a video for you. And it's going to be about this course I'm taking called Probability and Combinatorics. And what we're going to be talking about in this video is the information that was covered in Module 1 of the course. So we're going to go over the coursework for Module 1 of the course. So the first thing that we're going to cover is factorials. So in order to, and a factorial is where you multiply, like you've got a number 8. So you multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that is a factorial. And so Python gives you the ability to calculate factorials in their inbuilt math module. So what you do is you import math and your number is 8 and factorial equals math.factorial brackets num. And you print the factorial and it's 40,320. So the next question that we have with regard to factorials is you have 3 species of flower and they need to be arranged in 2 vases. How many combinations can you make? So you've got a formula to do that. So n is your number, and so n factorial divided by n minus r factorial. And so the number of species is 3, and the number of vases is 2. And so you get your total combinations equals math.factorial num species divided by math.factorial num vases. Num species minus num vases. So the factorial of num species is 6 because it's 3 times 2 times 1. And then the num species minus num basis is 1. So that's 1. So 6 divided by 1 is 6. The next question we have is you have 8 books but only 5 slots to put them in. How many different combinations can you make? And again, you've got the same formula. And then so what you do is you import math. So the number of books is 8 and the number of slots is 5. So total combination equals math.factorial number of books. So that's going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by math factorial number of books minus number of slots. So that's 8 minus 5 is 3. So that's 3 times 2 times 1. And then so you do all that with Python. You don't have to calculate it yourself. And after you've taken the 8 factorial divided by 3 factorial, you come up with 6,720. So now we have our fundamental principle of counting, and this is a multiplication. So again, how many combinations of outfits can you make with 4 blouses and 3 skirts? So blouses equals 4 and skirts equals 3. Combinations equals blouses times skirts, which is 12. So you can have 12 different outfits with 4 blouses and 3 skirts. So now you have the fundamental principle of accounting again, and this is doing the power of. So you forgot your code to a 3-digit lock. How many code combinations can you make in the lock? So the formula is m to the power of n. So the number of places is 3 and the number of digits is 10. So 10 to the power of 3 is 1,000. So total combinations equals num digits to the power of num places, and it gives you 1,000. You're also able to calculate permutations in Python, and their inbuilt math module has a perm function which allows you to calculate permutations. So we have a question of multiplying permutations of 6p2 times 3p3. So N1 is 6, R1 is 2, N2 is 3, R2 is 3. And so we calculate the permutations. Result equals math.perm N1, R1 times math.perm N2, R2, and the result is 180. So now what you can do is you can add the permutations. So you have 7p2 plus 4p1. And again, you import the Python's inbuilt math function. So N1 equals 7, so I messed that up, didn't I? R1 equals 2, N2, see if I can get that. N2 equals 4, and R2 equals 1. So let's see if we can get this. So we have a permutation function. So def, that should define your function, permutation n, r. So return math factorial n divided by math factorial n minus r. So perm1 is permutation n1, r1, and perm2 is permutation n2, r2. And so you have the result of perm1 plus perm2 equals 46. So you've got the, so basically you've got 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 minus 2 is going to be 5. So 5 times 2 times 3 times 5 times 4 times 3 times 2 times 1. And then you're going to have plus, for N2 is 4 times 3 times 2 times 1. And minus 4 minus 1 is 3. So it'll be 3 times 2 times 1. And when you calculate all of those, it gives you a result of 46, which Python does that for you automatically, so you don't have to calculate it. So now we have the question 7p2 plus 4p1, and we're going to import math. So again, N1 is 7, R1 is 2, N2 is 4, R2 is 1. You also have the perm function. So result equals math.perm N1, R1 plus math.perm N2, R2. And again, it gives you the same result of 46. So now we have a question. There are 5 children on the high school math team. How many ways can these 5 children be arranged for the team's yearbook photo? And so you're going to import Python's inbuilt math function. You have the number of children is 5. And calculate the number of arrangements, which is permutations. Arrangements equals math.factorial n, and so that's 120. So you can arrange the pictures 120 times, 120 ways to arrange the pictures. So another great thing about Python is you can also do permutations with words. So from either tools, import permutations. So word to permute is the word Barker. So generate all permutations of the word. All permutations equal set, brackets, permutations, bracket, word. And so you convert each permutation tuple back to a string. So unique permutations equals space dot join P for P in all permutations. And then we print the number of unique permutations, which is 360. And then you print the unique permutations. So it gives you 360 ways that you can spell the letters in the word Barker. So it also gives you banana. So perform a permutation in the word banana. So from either tools, import permutations. So the word to permute is banana, and we generate all permutations of the word. So all permutations equal set, brackets, permutations, brackets, word, and unique permutations equal space dot join P for P in all permutations. So we print the number of unique permutations, which is 60, and you can see that we printed all the unique permutations. So another question we have is perform a permutation on the word Mississippi. So you import math. So the total number of letters in the word is 11, and the frequencies of each repeating letter is M equals 1, frequency M equals 1, frequency I equals 4, frequency S equals 4, frequency P equals 2. So we calculate the number of unique permutations. Unique permutations equals math dot factorial total 11 letters, and that's 11. And it's going to be a floor division, brackets, math dot factorial frequency M times math dot factorial frequency I times math dot factorial frequency S times math dot factorial frequency P. And the number of total unique permutations that you can come up with is 34,650. So we have another way. Another thing that you can do is you can perform a permutation on the word parallel. So you import Python's inbuilt library math. So the total letters is 8. The frequencies of each repeating letter is frequency P is 1, frequency A is 2, frequency R is 1, frequency L is 3, and frequency E is 1. So we calculate the number of unique permutations. So unique permutations equals math dot factorial total letters, and then you're going to do floor division. Math dot factorial frequency P times math dot factorial frequency A times math dot factorial frequency R times math dot factorial frequency L times math dot factorial frequency E. And it gives you 3,360 total permutations. So now we're going to find the number of permutations in the word biology. So we're going to import Python's inbuilt math library or module. So the total number of letters is 7. So the frequencies of repeating letters is frequency B equals 1, frequency I equals 1, frequency O equals 2, frequency L equals 1, frequency G equals 1, frequency I equals 1. So we calculate the unique permutations. So unique permutation equals math dot factorial total letters, and then you do floor division, math dot factorial frequency B times math dot factorial frequency I times math dot factorial frequency O times math dot factorial frequency L times math dot factorial frequency G times math dot factorial frequency Y. And the total number of unique permutations is 2,520. So we have another question is find the total number of permutations in the word excite. So you're going to import Python's inbuilt math module, and the total number of letters is 6. So we get the frequency of repeating letters. frequency E equals 2, frequency X equals 1, frequency C equals 1, frequency I equals 1, frequency T equals 1. And then you calculate the unique permutations. So unique permutations equals math.factorial, total letters, and it's going to be floor division, math.factorial frequency E times math.factorial frequency X times math.factorial frequency C times math.factorial frequency I times math.factorial frequency T. And the total number of unique permutations is 360. So we have the last question is find the number of permutations in the word access. So we're going to import Python's inbuilt math module, and the total number of letters is 6. The frequencies of repeating letters is frequency A is 1, frequency C is 2, frequency E is 1, and frequency S is 2. So we calculate the unique permutations. Unique permutations equals math.factorial, total letters, the floor division, math.factorial frequency A times math.factorial frequency C times math.factorial frequency E times math.factorial frequency S. And so the number of unique permutations is 180. And so that completes the coursework for Module 1 in the course Probability and Combinations. So I hope that you got some insight in how to calculate factorials, combinations, and permutations in Python. And my next video is going to be how to do it all in Excel. So thank you so much for watching my video. If you like my video, please like and subscribe, and I will be making another video for you soon.